Okay, class, what we want to do is finish up the 9-5 notes. We got the harder part done by doing the chart and the powers of I. Now let's just talk about complex numbers. Rectangular form of a complex number is what you're used to. I'm not sure if you're used to having it called a rectangular form, but rectangular form of a complex number. This first part represents the real number, and then the second part is the imaginary portion, the BI, B standing just for some number multiplying by I. The pure imaginary, in a pure imaginary number, you don't have any real parts. So I end up with 0 for my real number plus BI. Well, we can see how that shortens up to just BI. So you get just the imaginary portion of it. Complex conjugates. Useful when we're trying to work with division of complex numbers. So a complex conjugate, normal form of a complex number is a plus bi. The conjugate to that is a minus bi. So instead of plus, we have minus. So if I go into an example, 7 plus 8i, its conjugate would be 7 minus 8i. 5 minus 2i would be 5 plus 2i. The third one here that's a little bit trickier, the conjugate of negative 3 plus 4i, the conjugate will still be negative 3 because you'll notice that a is a in both parts. It doesn't say the opposite of a, it just says a. So in this one, my a is negative 3, and then I change the sign here, that'll become a negative and 4i. So make sure you notice that change on conjugates. The real portion stays the same, and the imaginary part is the opposite of. Operations with complex numbers, adding, subtracting, and multiplying. Then we'll look at division. Addition, very simple. Add the real part with the real part and the imaginary part with the imaginary. So probably easiest is to just stack this number underneath, add them together. I'm adding real portion with real portion. That gives me 1, and imaginary part, imaginary with imaginary, that's going to give me negative I. Final answer, 1 minus I. Subtraction, I am going to distribute my negative. So that gives me 5 plus 8i plus 3 minus I. I'm going to line up the second imaginary number, and then I can just add these two together since I had already distributed the negative. Adding them together, I get 8. 8 plus 7i, final answer. Squaring, just like all other squarings, it means multiply it by itself. So I'm going to write it down as a factor multiplying itself. I'm going to FOIL this together. Negative 4 times negative 4 equals negative 16. Negative 4 times 2i gives me negative 8i. And now my inners, another negative 8i, and my outers, positive 4 and an I squared. This makes negative 16 minus 16i, joining those two middle-like terms. And then I have plus 4i squared, which is the same thing as negative 1. That makes this actually negative 4, doesn't it? So I'm going to take negative 4 with negative 16, getting negative 20 minus 16i. And it's written in the nice rectangular format with the real part, negative 20, and the imaginary part second, negative 16i. The last problem here showing multiplication, distributive property. Take and distribute it through. I'm going to get 4i cubed minus 3i raised to the 4th. I can simplify out these i's. I cubed is the same thing as negative I. I to the 4th is the same thing as 1. You could look back at the chart that we did on screen number 1 if you needed some help with that. I get negative 4i minus 3 but I should write it in the nice rectangular format. Lead off with my real number, followed by the imaginary. And there's our answer. Finally, a multiplication with three different terms. So I am going to multiply these two first, and then I'll come back and multiply by that factor at the end. So first, 8, outers plus 4i, inners negative 4i, last times last minus 2i squared. Positive 4, negative 4, they disappear. I get 8 minus 2, negative 1 replaces that I squared because that's what it's equal to. That means I have 8 plus 2, making this 10. Don't forget, though, that I still have to multiply by 3 minus 4i. Distribute the 10 through, and I'm going to have 30 minus 40i as my final answer. Last one is division, and there is a rule that you cannot leave an I in the denominator. So what we're going to do is multiply this by the conjugate. Why don't you make yourself a little note on the side? Multiply denominator, multiply by conjugate of the denominator. So that's exactly what we're going to do. The conjugate to the denominator would be 5 plus 2i, and then I have 5 plus 2i. When I'm multiplying by that fraction 5 plus 2i over 5 plus 2i, that's really like multiplying by kind of a fancy 1. Doesn't change our original fraction that we started with. Multiplying the bottom, first times first, the middle values come positive 2i, negative, I'm sorry, how about positive 10i, and then a minus 10i. Last times last would give me minus 4i squared. There's my denominator, but this can simplify. 10i, negative 10i go away. Minus 4 minus times minus 1 makes positive 4, so I get 25 plus 4. Looks to me like our denominator is 29. Keep that in mind. So I have something over 29. Now go to the top and FOIL out the top. 5 times 4 is 20. The outers produce 8i, the inners produce 10i, and the last times the last is 4i squared. Simplify. On top, I'm going to have 20 plus, that's 18i when I bring those like terms together, and a minus 4. 20 minus 4 is 16 plus 18i. So I'm going to end up with 16 plus 18i over 29. Final answer. And then homework will be that for tomorrow, and we will get started on that as soon as you get into class.